Hello and welcome. Let's walk through this physics challenge on the board. Imagine an electromagnetic wave with its E field in the y direction. Our task is to show that the first partial derivative of electric field function with respect to distance x is equals to the negative of the first partial derivative of the magnetic field function with respect to time t applied to the harmonic wave. So we are given the electric field function, which is the amplitude field strength cos parenthesis kx minus wt. And we're also given the magnetic field function to be amplitude magnetic field strength, okay, cos parenthesis kx minus wt, yields the fact that the amplitude field strength of the electric is equals to the product of the speed of electromagnetic wave and the amplitude magnetic field strength. All right. So which means because we are given the electric field function, which is E naught cos parenthesis kx minus wt, the first partial derivative of the electric field function with respect to x will be the product of E naught negative, because when we differentiate cos, we get negative sign. So negative k, okay, sine parenthesis kx minus wt. Because when it comes to partial derivative, because we are differentiating with respect to x, so it means wt will be kept, will be kept as a what? Constant. So we'll keep this as constant. All right, so when this is kept as a constant, and differentiating cos will give us negative sign. Okay, then because we are differentiating with respect to x, so differentiating cos kx, that will be equals to negative k sine, kx. Okay, all right. So in this case, we're going to have minus E naught times k sine kx, okay, minus wt. So the first partial derivative of the electric field function with respect to x is equals to the product of E naught k then sine parenthesis kx minus wt. Okay, now we're also giving the magnetic field function, which is B naught, okay, cos parenthesis kx minus wt. Now, the first partial derivative of the magnetic field intensity, okay, with respect to time t. Now we are differentiating with respect to t, okay. So it means we are going to keep this as a constant, so that this will be b naught multiplied by negative w, okay, multiplied by negative sine kx minus wt. Okay, so now negative times negative, that will be positive. So in this case, we are going to have w b naught sine parenthesis kx minus wt. That will be equals to the first partial derivative of the magnetic field function with respect to time t. Now, what we have here is that the first partial derivative of the electric field function with respect to x, okay, is equals to the negative of the first partial derivative of the magnetic field function with respect to time t. So which means I'm going to set this equals to this. So for this over x minus this over time t. So we know that this gave us negative E naught times k sine parenthesis kx minus wt. And this is equals to negative w b naught sine parenthesis kx minus wt. So if we divide both sides by We divide both sides by negative sine sine parenthesis kx minus wt. Okay, this will cancel from both sides. So we'll be left with E naught times k equals to omega times b naught. Okay, and now I'm going to divide both sides by k. Okay, divide both sides by k, which is propagating constant or wave constant. So we're going to have E naught times k over k equals to w over k multiplied by b naught. So k cancels k. Then we'll be left with E naught equals to w over k multiplied by b naught. Now, c is equals to w over k, that is speed of electromagnetic wave, can be expressed as a ratio of what we call angular frequency to the what? Wave constant or propagating constant. All right, so in this case, we're going to have E naught to be equals to C multiplied by B naught. And this is how to show that the first partial derivative of electric field function with respect to distance transverse x is equals to the negative of the first partial derivative of the magnetic field function with respect to time t, yields the fact that E naught is equals to the product of speed of electromagnetic wave and amplitude magnetic field strength. The noblest pleasure is the joy of understanding. Bye-bye.